Hi, today we are going to look at a parallel and a perpendicular slope. So realize that these two lines here, they are parallel here, but I want to confirm more with their slopes. So we can call this one M1 and the line M2. So let's find the slope of M1. So here we pick any reasonable point. So if we have point here, and let's say the point here, and then we draw a small triangle here. So we want to find their slope, and we are using rise or run formula to find the slope. So here we realize that it's going up 1, 2, 3. So for the M1, it's going up 3, and then it's going on the horizontal, which is the run by 2. And the line is going down the hill, so it's negative here. So that's the slope. Then we come to the line M2. We pick any reasonable good point. It could be anywhere, but it have to be a reasonable. That's going through the edge. So we can pick here and here. And we know that they are meeting here, so we draw a little triangle here. And we see that it's rising 1, 2, 3. So the M2 is rising 3, and it's on the horizontal 1, 2. It's going down the hill, decreasing, so it's negative. So here we realize that slope of M1 is equals to a slope of M2, which is equals to negative 3 over 2 here. So here we can conclude that these two parallel lines has the same slope. So here, that's the reason why we say that the parallel lines has the same slope. That's M1 is equals to M2. Now let's look at these two lines. We can also call them M1 and M2. We assume that these two are perpendicular, and we want to find their slopes. So for the M1, let's pick any reasonable points to find our slope. We can find any reasonable. You have to go through the edge. So I can use here and here. Okay, I know they are meeting somewhere here. So I'll draw my little triangle. So we are still using rise over run. For the M1 here, we see that it's rising 1, 2, 3. It's rising 3 over. It's running 1, 2, 3, 4, 5, running 5. And this line is going down, so it's negative. Now let's come to this M2 to pick any reasonable point to find the slope and see what is happening. So over here too, we can pick any reasonable going through the edge, so we will make a dot here. Going through the edge, we make a dot here, and then we pick another one here. So we see that they are meeting here. We draw our lines here. For our M2, realize that it's rising 1, 2, 3, 4, 5, and it's running 1, 2, 3. This is going up the hill, so it's a positive slope. We leave it like that. Our observation about these 2 points is that the M1, M2, there is a negative and there is a flip or reciprocal of M2. So look at here, it was 3, now 3 is down there, so it flipped, and this was down, is up. there was a negative here and it's positive. So what happened is a negative times negative. Here concludes that when you have a perpendicular lines, their slope is negative reciprocal. Another thing that we can also do is that when we multiply m1 times m2, you have to give us -1. And we could do that if we multiply. So when we multiply -3 over 5 times 5 3, realize that we're getting -3 times 5 give us -15, and 3 times 5 give us 15, which is equals to -1. So another one that we can also say is that when you multiply the two slopes of a perpendicular lines, you have to get -1. Okay, so this is the basis. Now we are going to use it to solve examples. Okay, so let's use it to solve examples. So we have a line y is equals to 4/3 x here. So here the slope m1 is equals to, if we use y is equals to ms plus b, this is the slope. So therefore this one is a slope. So we got 4/3, but for a perpendicular slope, let's call it m2, we have to give it negative, and we flip this, come here, let's go here, so that become -3/4. Now here, what is the slope of the line parallel to y is equals to 7/4 x here? So here realize that the slope m1 is 7/4. So our new slope that has to be parallel to that slope is m2 is also 7/4, because it's supposed to be the same. We have been given y is equals to 3x plus 2. Remember, we will be referring to ms plus b, or some people in the Europe, Africa, China, we use plus c. All of it is the same. And the m is a slope, and the b and the c is a y-intercept. Okay, we are interested with slope now. So here the slope, which we call it m1, is 3. Remember, every slope is like a fraction, so here there's no number, we can put 1 here, and we have been given a point 5 3. And anytime you have a point and a slope, remember you use y minus y naught, or some people say y1, all of them are the same, and x minus x naught, such where the x naught and the y naught is the point. Okay, so here we want to write an equation that is going to be parallel to this given equation here, the slope and the point. So here, since it's parallel, the slope have to be the same. So our parallel slope, which is m2, has to be also 3. Now we want to write the equation. So we have a point and we have a slope. So we will write that as y. This is our x naught and our y naught. So y minus 3 is equals to the slope, and then x minus 5. Here we would like to distribute. We will distribute this to that and this to that. So if we distribute, we will get 3x minus 15. And we want to isolate the y, so we will add here 3, and we have to repeat the same thing here. So we will get y is equals to, this will go away, get 3x, and then we get minus 12. So one thing that we see that the slope is still the same. And then if we graph this one, we will realize that the lines will be parallel lines. Okay, so now we want to consider the perpendicular slope, which is M2. The M2 has to be negative, so negative, and we have to flip this. So 1 go here, and then the 3 come down. So it's going to be 1/3. So that's the new slope. And we are using the same point for that equation. So we get y minus 3 equals to negative 1/3, and the x minus 5. We can distribute if we want. And then this time that gives us negative x over 3. And here negative negative become positive 5/3. And then we have to add here 3, and we have to add here 3. Okay, this goes away. Since it's a fraction, so we can put 1 here. So what we are going to get, running out of space, going to get, so y is equals to negative x over 3 plus here we take this, we multiply this, and we use a crisscross, and then we multiply this and that. That will give us 5, and we multiply this crisscross here. That will give us 9, and then we have over 3. We add that, we get 14, so plus 14/3, and we are done. If you need help on adding fractions, I have a separate video on that, so you can look at that. And all this distribution too, I also have a video on that. So this here, realize that if you graph this equation of a line and this given line, you will see that they are going to be perpendicular to one another. Okay, so we have a table, and they want us to find the slope, and then we find the parallel and the perpendicular slope to that. So here is a table. We can pick any 2 reasonable numbers. It doesn't matter whichever you pick, you will get the same. I will select this one, and I will select this one here. So we got 0, 3, and we got 2 and 11. So 2 points, and if you have 2 points and you're finding your slope, it have to be y2 minus y1, x2 minus x1. Okay, we have done a lot video about this, so you can look. Normally I say connect this to this and connect this to this, and then find a difference. So here the m1 will be just 11 minus 3, and then 2 minus 0, which will give you 8/2, and thus you get 4. You can put 1 here if you want. We are looking for, if we are looking for a parallel slope, this is a parallel slope 2. It's going to be the same 4/1. And if we want to write the equation for that, it will be much easier for us, because this point here, since x is 0, this is indeed a y-intercept. There is a, so that will be much easier. And then they want to write the equation with respect to this given point here. So it will be just y minus 5, the slope is here, so 4x minus 2, which become y plus 5 equals to 4x minus 2. We can leave it as this. We are not going to distribute because yeah, we can leave it as a point slope form. Doing perpendicular, it's going to be negative, and we flip. So that's the negative slope, which is the m2. But that's negative flipped. So for us to find the equation with respect to the same point, it's just going to be y plus 5 equals to negative 4x minus 2. We can leave it as that too. Okay. Now let's look at the next. So here we have a line and we need to find the slope. So yes, we can just join this and use rise over run. So it's run 1, 2, 3, 4. So we are using rise over run, which give us 4. And then it's running 1, 2, 3. 3. The line is going up, so it's a positive slope. And this is the M1. Okay, so for us to find the parallel slope, which happens to be the M2 here, it's just going to be the same. And for us to write the equation for this point, at this point, is going to be y plus 1 is equals to 4, 3x. Negative negative becomes plus, so plus 2. Okay, so here the reason why I'm not explaining much is that we have done a lot about this point slope form, so just you can review that and catch it from there. So we can leave it as such. So if we look at the perpendicular M2, we realize that the slope is going to be negative, and you flip. So that's that. And at the same point, I'm going to write the equation for this perpendicular line. It's going to be y minus 1 equals to this slope, which is negative 3 over 4, and then x minus 2 become y plus 1 equals to negative 3 over 4, and then x plus 2. And we are done. Please subscribe and leave a comment and like it. See you in the next video. Thank you for watching.